INSAT 3D, an advanced weather satellite. The weather is a harbinger of life to a country like India, where 70% of the population, either directly or indirectly, depends on agriculture. It follows, therefore, that rainfall, temperature, humidity, and sunshine are highly critical for crop operations and information relating to these parameters of paramount value. Natural hazards like cyclones, floods, drought, cloudbursts, landslides, etc. directly affect life. Once again, weather forecasts giving accurate and timely prediction of these phenomena can spell the difference between life and death to those within the ambit of these occurrences. Weather forecasting also has a major impact on sectors like energy, sports, tourism, transport, and aviation. Hence, there is a constant thrust on improving weather prediction skills. However, for better prediction of future weather, we need accurate observation of current weather, and this comes from a network of ground observatories. The India Meteorology Department, IMD, operates a network of ground stations that provide vital weather parameters. This network, though, is not adequate and has large data gaps over several inaccessible regions such as oceans, deserts, and mountains. Satellites are the only platforms that can bridge these gaps and provide continuous weather observations over large areas. The country needed a satellite in order to meet the operational needs of its communication and weather services. A need that was ably met by the multi-purpose geostationary satellite, INSAT 1A. ISRO spared no effort to enhance the nation's weather observations and forecasting capabilities, and an entire series of INSAT satellites followed. Then came METSAT, the first exclusive Indian geostationary meteorological satellite. METSAT was renamed Kalpana 1 in memory of the Indian-born astronaut, the late Kalpana Chawla. It must be remembered that there are polar orbiting satellites that have a limited frequency of observation, typically only a few times a day. However, frequent observations are necessary to predict the rapidly changing atmosphere. For short-range weather prediction, the most important parameters are the atmospheric temperature and humidity profiles. The only alternative to acquire frequent coverage is from a geostationary platform, and this is being realized through INSAT 3D.
INSAT 3D is an advanced weather satellite of India to be placed in the geostationary orbit at a longitude of 82 degrees east. It will add a new dimension to the meteorological observational capability of India. Currently, we have 2 satellites providing imaging capability from geostationary orbit, the Kalpana and INSAT 3A.
INSAT 3D will be launched in July 2013 by Ariane 5 from French Guiana. The spacecraft will be placed in a geostationary orbit at 36,000 km and positioned at 82 degrees east. INSAT 3D is configured on a standard 2074 kg I2K spacecraft bus with expected lifespan of 7 years. It will carry a 19-channel sounder along with a 6-channel imager, data relay transponder and satellite-aided search and rescue payloads. These payloads have been designed and developed at Space Applications Center, Ahmedabad, and integrated and tested with the INSAT 3D spacecraft at ISAC, Bengaluru. The INSAT 3D mission also has contributions from several Indian industries.
In INSAT 3D, we have made significant improvements in the imaging system. In the sense, we have added imaging in the middle infrared region, enabling us to take pictures of clouds in the night. We have also made improvements in the thermal infrared imaging system so that we could estimate sea surface temperature more accurately that are required for the weather prediction system. But the most important part of INSAT 3D is the atmospheric sounding system. This sounder provides us profiles of temperature, humidity, and critical trace gases. This is going to be really a boon for the country for weather prediction and disaster warning.
The imager will scan the full Earth disk in less than 30 minutes, whereas the sounder will scan Indian landmass every hour and Indian Ocean every 6 hours. These scans will give us information about the three-dimensional structure of temperature, humidity, and ozone. Variations in atmospheric temperature and humidity give rise to severe weather conditions like thunderstorms and tornadoes. Thus, information from the INSAT 3D sounder will help predict severe weather. Observations in different sounder bands are sensitive to the radiative energy emitted from different vertical layers of the atmosphere. These sounder profiles are used to derive total water content and atmospheric stability indices that indicate the location and time of severe weather events. The imager consists of 6 channels, of which 2 provide high-resolution imageries of the Earth during daytime, and 4 infrared channels provide observations both during the day and at night. The INSAT 3D imager will provide images which are 4 times sharper than those provided by earlier INSAT satellites. As a result, observations of cloud, atmospheric wind, and oceanic thermal fronts will improve. The imager also has a special programmable scan mode, which can focus over a smaller area and provide frequent observations. This is especially useful while tracking cyclones and other fast-changing weather events. In addition, INSAT 3D imageries with enhanced spatial resolution will also provide an excellent insight into the patterns of cyclonic activity over India. This will help in improving the cyclone track prediction and intensity estimation that will immensely benefit society. For the first time, INSAT 3D will provide accurate observation of sea surface temperature that has applications in weather, ocean, and climate studies. Accurate observations of sea surface temperature will lead to improved identification of potential fishing zones. Other new products from the imager include fog, forest fire, smoke, snow cover, and various agro-meteorological parameters such as radiation, land surface temperature, etc. The INSAT 3D imager will also ensure continued observations of parameters such as precipitation, outgoing long-wave radiation, and upper tropospheric humidity that are essential for monitoring long-term variability of weather and climate. Transport and movement of atmospheric pollutants such as dust and aerosols can be identified and tracked using high-resolution visible imageries. INSAT 3D data have great potential to improve weather prediction using numerical models. These models require observations of land, atmosphere, ocean parameters such as temperature, winds, humidity, soil moisture, snow cover, vegetation, etc. Data inputs from INSAT 3D will significantly improve short-range weather forecast of events such as heavy rainfall, thunderstorms, heat waves, cold waves, besides fog detection and visibility to help the aviation industry. The India Meteorology Department, IMD, and National Center for Medium Range Weather Forecasting will use this data to provide improved weather forecast. INSAT 3D satellite data products will transcend national boundaries and be used in real time by operational and research institutions globally. It is a matter of national pride that the entire data processing for INSAT 3D imager and sounder has been developed at SAC Ahmedabad under INSAT Meteorological Data Processing Systems, that is IMDPS. The system will be operational at IMD as well as SAC after the launch of INSAT 3D. Since this is the first time that such a complex data processing system involving infrared sounder has been developed, there was a need to test this before actual satellite launch. SAC developed an innovative method to test the entire processing system by creating synthetic data set for imager and sounder channels from available global operational satellite systems. This exercise has successfully demonstrated the capability of INSAT 3D data processing system. INSAT 3D will also carry a data relay transponder and satellite-aided search and rescue payloads. The data relay transponder will help in collecting global meteorological, hydrological and oceanographic data, while the search and rescue payload will help in distress situations for rescue operations in disaster management. The geophysical data products of INSAT 3D will be disseminated through IMD New Delhi and through Meteorological and Oceanographic Satellite Data Archival Center, that is MOSDAC of SAC Ahmedabad, for operational utilization as well as for research and development. INSAT 3D is an outstanding example of India's technological and scientific strengths in harnessing space technology for the development of the country. Its benefits are multifarious, extending from farmers and fishermen to people living in drought and flood-prone areas, and from decision makers to different agencies and administrations. The launch of INSAT 3D is a major milestone for India's space program, which will greatly enhance our capability to observe, understand, and predict the weather.